Good evening, friends. I welcome you to today's lesson. Tonight, we are going to talk about allotropy. We are going to study allotropes, and in specific, we are going to look at the allotropes of carbon. Feel free to ask your questions. You can stop me at any time, and I'll be more than glad to answer your questions. What is allotropy? What is an allotrope? Allotropes, by definition, are elements in different physical forms, but in the same physical state. In other words, we can define allotropes as the different forms of the same element in the same physical state. When an element has different forms, but the same physical state, we call it an allotrope. The carbon we are talking about has many allotropes. Okay, 4 examples of allotropes: we have graphite, we have diamonds, we have graphene. Those are just but few examples of the allotropes of carbon. Now, this evening, we'll just focus on 2 allotropes of carbon, that is graphite and diamonds. What is graphite? Graphite is a soft, black, crystalline form of carbon. So it is soft, it is dark in color, and it is crystalline. Graphite is also a fair conductor of electricity, and it is made up of flat sheets of carbon atoms. So the first allotrope of carbon, which is graphite, is dark in color. Okay, and this is something that we already know. Okay, the heart of a pencil, for instance, the heart of a pencil is made out of graphite. So that dark thing we see in a pencil, that's what we are talking about. That is what graphite is. Okay, so it is crystalline by nature. Graphite is dark, and it is also soft. Now, that graphite is basically made up of carbon. Those are carbon. That is carbon. It's a carbon element. What are some of the physical properties of graphite? Number 1, graphite is a good conductor of electricity. Graphite is a good conductor of electricity. That simply means electricity can flow through a graphite conductor. Number 2, graphite is soft and slippery. Graphite is soft and slippery. Number 3, we just saw that graphite is actually used in a pencil. It is the heart of a pencil. Graphite can be used to write on paper. That is the reason why it is used in pencils, because it can write on paper. The 4th property of graphite is that it has a density of 2.22 grams per cubic centimeter. And lastly, graphite has a high melting point. It has a high melting point. This is because it has strong bonds between its carbon atoms. So those are the physical properties of carbon. Good conductor of electricity. It is soft and slippery. It can write on paper. It has a high density and a high melting point. Now, this graphite is not that hard. This graphite is easily broken. Graphite can easily be broken. That is one interesting thing you are supposed to note. Graphite can easily be broken. And I think you can actually experiment this. Get that pencil that you have and the graphite heart. Try to break it. You will see how easy it can be broken. So graphite is not that hard. Graphite can easily be broken. What are some of the uses of this graphite we are talking about? Number 1, graphite is used as a lubricant. because the carbon atoms can slide over the other atoms, it can be used as a lubricant. Number two, graphite is used as an electrode. Under electrolysis, when you look at most of the electrodes are made up of graphite. Some of the electrodes can be made out of graphite. Now, an electrode, by definition, this is a solid conductor used in electrolysis. It's a solid conductor used in electrolysis. So graphite is one of those electrodes that we use in electrolysis. Number three, graphite is used for making pencils. The heart of a pencil is made out of graphite. It's made out of carbon. That is carbon, and that is graphite. So those are the three basic uses of graphite. It is used as a lubricant. It can be used as an electrode. And number three, it is used to manufacture or make pencils. So this is the first allotropy of carbon, graphite. The other one is a diamond. So carbon also exists in form of a diamond. Now, we will discover that allotropes have different properties. Okay, it's the same element, but they look differently and they have different properties. For instance, this diamond that we are talking about now is a colorless crystalline solid with an extremely high density. So we can already see some similarities, of course. Graphite is crystalline, diamond is also crystalline. But there's a difference. Graphite was dark, it was black in color. But diamonds are colorless, they are colorless solids. Now remember, allotropes must be in the same state, same physical state. Graphite is a solid, diamond is also a solid, okay? But the difference, we have noted it, a diamond is a colorless substance. Now, diamonds are something that you all know, okay? I'm sure at some point you have seen a diamond before. In case you have not, it's right there on your screen. Those are the shiny crystals we are talking about. That is what a diamond is. What are some of the physical properties of the diamonds? Number one, diamonds are the hardest substances ever known on planet Earth. So unlike graphite that is easily broken, diamonds are the hardest substances. They are not easily broken. As a matter of fact, they are very hard, such that their melting point is 3,700 degrees Celsius. Okay, now that is a high melting point. That is a high melting point. That is number one. Number two, diamonds are colorless and transparent with dazzling, brilliant luster. So diamonds are colorless. Diamonds are also the hardest substances you will find on planet Earth. Number three, diamonds have a density of 3.5 grams per cubic centimeter. And lastly, the diamonds do not conduct electricity. Unlike graphite, diamonds will not conduct electricity. Okay. What are some of the uses of these diamonds we are talking about? Number one, diamonds are used for cutting tools. Because diamonds are the hardest substances on planet Earth, they can actually be used to cut other tools. So diamonds can be used to cut other tools and other devices. Number two, diamonds are used to cut glass. For you to cut glass, you actually use diamonds, and you can cut glass well using a diamond. So there are many other forms of allotropes. We are going to tackle the other remaining allotropes in the next lesson. Thank you so much.